Hey guys, welcome back. So continuing straight on with the Ivy generator, let's make a start on our first L system rules. So I'm going to drop down a geometry node, place down an L system and jump over to the rules tab, and this is where we're going to start building our own rules. So we can delete these rules that make up the tree, and as you would expect, everything disappears. So what we need to provide first is this thing called a premise. This is going to be the starting point for the system. So we need to provide it a rule that will kickstart all this recursion. And we're just going to start off with a rule that we're going to define, and that's going to be a capital X. Okay, so for the premise, it'll initialize with X. So here we can start specifying what X is. Okay, so just like we did in Photoshop, we can say, I want you to move forward, and then I want you to create a branch, turn right and then move forward, and then end that branch. Then what we can do is we can utilize another command, which is capital H, which means move forward but half a step, and then create another branch, and then close that branch off. And let's see what that gives us. Okay. We'll just turn on point displays and just let's analyze what's going on here. So we've got our rule and we're calling it with the initial premise of X, and it's going F to move forward, create a branch, turn right, move forward, and that's this section here, and then it pops back. H is move forward but half a step, and here you can see this distance here is roughly half of the full distance. But this time turn left and create a branch. So we've got this. And at the moment, we're not really doing any recursive stuff here, even though we've got 7 generations. If we just slide that back, you'll see it's doing everything without recursively acting on it. So what we need to do is at the end of this rule, we need to call it again. So we can just put capital X at the end there. And there you go, you can start to see we've got a basic plant-like structure already in just that very, very simple rule. What we're going to do now is start introducing a few more commands, a few more turtle commands. And again, I'd strongly recommend you work with the documentation open and just navigate to this section here called Turtle Commands Reference, because what we'll be doing is I'll be introducing quite a lot of new commands. You'll be able to see what they do as it sort of straight away in the viewport. But ultimately, if you want to get into working with L systems, you're going to have to become very, very familiar with this language of these rules and what they do and how they can help you. So here we go. We just let's analyze the ones we've looked at so far. We've used F to move forward, pretty straightforward. And then we've used capital H, and that's move forward half a length. And we've used the branching and the turning and things like that. The next rule that I want to introduce is this speech mark, quotation mark, speech marks, quotation mark. So if we put that before we loop back on our rule, you can see what's happening now. Every single iteration is multiplying the length by a certain value. Okay, so it's getting progressively smaller as it goes up. And that quotation mark there is driven, if we jump to the values tab here, it's driven by this step size scale function here. So if we bring this right down, you can see the top of the plant really starts to shrink down. Okay, so I mean, you can eyeball this to whatever you need, but roughly something about 0.8, 0.9, which means every single generation it's going to get progressively small. It's going to multiply that value by 0.9, 0.897. So we're going to have progressively smaller step sizes per generation. Let's just up the generation count to something like 12, so we can start to see the stem of our ivy leaf sort of coming together. Next thing we want to do, it's very uniform at the moment. We want to introduce a little bit of randomness, a little bit of noise into our stem. So we can do that again before calling back on our iteration. So before recursively coming back to the next iteration, we want to apply some noise, and we're going to use this tilde. I think that's a tilde, correct me if I'm wrong. It's just above the hash key on a UK keyboard. I think that's called a tilde. And what that one does is, if we scroll to it here, in the rules somewhere, there we go. So this will pitch, roll, turn a random amount up to a degrees. So any variable that you put in brackets there, it's going to rotate and randomly roll that amount. Okay, so let's just see what that gives us. So its default value is 180, and that gives you something quite chaotic and a bit too chaotic. So we can control that using that a value. And you could directly put in a number like 10, and you get sort of a nice wavy kind of little bit of noise. But there's a couple of ways we can take this further. So I'm going to plug in the variable b and jump back to the values tab here, and you'll see this variable b here is currently set to 1. If we play with this value now, we can start to add in the noise to our system. Okay, so you can start to see we've got this variable noise all the way up the stem. Ideally, what we'd like, if we're looking at our reference imagery, is we want, let me find a good example of it. Sort of this example here, you can see at the bottom of the plant where it gets quite thin, there's quite a lot more noise than at the top of the plant. Okay, so where it's quite structured, the stems are a little bit heavier, it tends to be less noisy. So we can emulate that by iterating a value every generation. Okay, so at the lower generations we want that number to be quite low, but as we get towards the end here, we want the noise to be quite prominent. Okay, so we need to multiply that value by the generations. And we can do that by initializing a value in our premise. So we can say x initially has a value of 1. So that's going to be, say, one degree of noise. Okay. And then here, where we're generating that noise, we can, every generation, multiply that. So it gets, every generation it will get progressively bigger. Okay. So in the brackets there where we're specifying the value, we can say I multiplied by, and we'll keep these values really low just so we can sort of keep control of it. We'll multiply it by 1.1. So it's every generation is going to increase in size a very, very small amount. Okay, and then we can multiply that by our variable b. Okay. So now what you'll see is we've got sort of very little noise at the lower generations, but as we go up, we're starting to increase that noise value by quite a lot. And we can still drive it using this variable. No, hang on, got that wrong. We want to put that at the end there, I multiplied 1.1. So when we recursively call that x again, we're taking the I value and we're multiplying it by 1.1. Okay, so there we go. And as you can see now, the lower generations are receiving less noise than the ones at the very top here. And we've got some nice control over how much of that noise is. Okay, so this is the section here that's adding the noise. Tilde, and then we're taking that I value and then we're multiplying it by our variable here. And then before we iterate back, we're increasing or incrementing I by 1.1. Okay, so it's given us some nice control over how noisy we want the end of the plant. Okay, cool. So the next thing I want to do very quickly before moving on, just so I can visualize things better, I want to sort of just drop in a quick proxy geometry for leaves so we can start sort of visualizing how the plant looks with some leaves on it. So I'm very, very quickly going to drop down a circle, just change that over to NURBS, and I'm going to plug that into the first input of the L system. And if you hover over, you can see the first input is leaf J input. So every time we reference the rule J, it's going to put down a leaf. Okay. So where do we want our leaves to appear? Well, we want them to sort of roughly be where the ends of these branches are. So we know where we're creating these branches. It's in these brackets here. Okay. So if we say create that branch and then also drop down a leaf, so by calling the variable j, and again on the other side, variable j, I'm just going to go back to that circle and just drop the uniform scale a little bit. And in fact, let's go a bit mad and just edit this circle to be a bit more leaf shaped. So I'm going to press S to go to my select mode, 2 to go to points, select those, press T to go to edit. I'm just going to very quickly rough in a very quick leaf shape, and I've totally forgotten what a leaf looks like, and something like that. And then I'm going to plug that back into our leaf input. Okay. So there you go. There you can see our rule now is incorporating this leaf geometry. And in subsequent videos moving forward, we will use a photogrammetry scan of a leaf asset from Quixel to drive this. So we'll have some nice sort of leaf texture on each of those leaves. But as you can see, we're starting to build to where we need to be. We've got a nice bit of control with the randomness of the leaf. So we can sort of make it twist quite as much as we want. And then if we wanted to generate variations of this, we could just play with the random seed on the geometry tab, and you can see we get a different look per seed. So we're already sort of creating a lot of variety straight off the bat. Okay, so I'll leave this video here. In the next video we'll continue on with the stem. I just want to introduce a few more concepts and a few more rules into the L system that will give us a little bit more control further down the line as we progress. So hope that was useful, and hopefully see you in the next video. Thank you very much.